Good morning and welcome to the next session. Since last session, which consists of two parts, we are talking about the fundamentals of microprocessor. I am trying my level best to explain to you in extremely simple manner, wherein I am choosing to go to requisite details which are essential, and if all details are to be studied, then it cannot be covered in the first year subject, which is there for all branches into the given structure of 2 hours a week. We would be meeting extra, but there has to be some limitation. Means what I have chosen is the details which are required to be understood from engineering point of view. I am going very deep, and some other details which are not so required at this moment. Those who are interested can pursue it later. I am just presuming them. So what we have done is that the theme of microprocessor is told to you. A microprocessor is a again I repeat, no, it's not repeat but recap you can say. Microprocessor is a non-living obedient servant. Microprocessor is non-living obedient servant. Being non-living, he is working objectively, and also it is not able to decide anything on its own. Everything is very well structured, well defined, and it proceeds very appropriately according to that. Now, to understand microprocessor in detail, now I think that the example of master servant is enough now. Don't need to go into a storytelling business. That is not our prime motto. So when we talk of the system, some fundamentals are essential to be understood. The first module of entire digital electronics is required to be basics, but right now, if we go through that, then more time would be lost and we will not be able to begin practical. So I am deferring those at a later stage and starting with the third module of in this syllabus, that is microprocessor. It is the Arduino fundamentals, and the Arduino is nothing but a microcontroller. A microcontroller is concept of microprocessor. So for understanding microprocessor, what is required is that the concept of memory. So in general, I will give you a block diagram of microprocessor. Then after giving the block diagram of microprocessor, that is the von Neumann architecture and the things which are required to be understood, I will elaborate in detail. So in general, microprocessor is a chip which it is von Neumann architecture. Von Neumann architecture. Now, I will try to explain it in very simple manner without presuming any prerequisites as such. Few of you who might have 12th vocational, that is the computer science, for them it is just repetition. But they will also get a good detailed, what we can say, upper hand over the subject. Now, what von Neumann has said, remember that von Neumann has said in 1946 that there would be a central processing unit which will be able to access memory with the help of address bus. Everything will be very clearly explained to you. Data bus and control bus with the help of address, data and control lines. CPU will be able to access memory which will contain program plus data. So just remember, when the first few sessions are further over, you will get a complete understanding of microprocessor working, which is more than enough for understanding the subject Arduino. So what von Neumann has said, so this is CPU. That this CPU, now this CPU is an orderly, just like who obeys the orders, just like a non-living servant. CPU is a non-living servant. So what it is supposed to do? This CPU is supposed to work as told to it by a program which resides in memory. By a program which resides in memory. So then in addition, despite it is I am explaining in very simple manner, despite it is orderly, it cannot take the first order from anybody, just like the copy sheet. Despite it is orderly, first order it cannot take from anyone. It must be hardwired by design inside it. So some additional features how CPU will start. For that I am adding here there is one reset pin. There is a reset pin. Once it is reset, CPU starts from a fixed, what we can say, point. It starts from somewhere which is fixed. Means just like that the master copy sheet is in my front pocket, that cannot be written anywhere. That must be written by the student, the mischievous students, with his own memory inside. Like that, from where CPU should start must be somehow inbuilt in it. And there is one more pin to it. I will explain it in a very systematic manner. One more pin to it is the clock. Clock pin. Just an example. Just like human beings, all operations take place on heartbeat. Similarly, these examples or the comparisons are given just for understanding purpose. Don't quote it anywhere else. So this clock is like heartbeat, that is, it schedules the various activities. Clock pin schedules various activities of microprocessor. So a clock. And also you presume that it's a convention, not essentiality, that one negative falling edge to next falling edge of the clock is called as one cycle. This is one clock cycle. One clock cycle. So somehow falling edge, that is from high to low, is considered as the initiation thing. So one falling edge to next falling edge, one clock pulse, one clock cycle. Okay. Now this is address bus. This is said to be data bus 8. These are 16 lines. Just von Neumann has not said that. I am assuming them. This is a read control line, bar and write bar. I will explain them in very simple manner so that you understand everything. Now this is memory which contains program as well as data. Just like also that very interesting thing I am explaining to you is, suppose you have got a student is going a copy sheet. He opens the copy sheet, reads something, and that is to be written. Are you getting me? The student has managed everything. The paper is available to him. The answer is, he is able to locate the question somehow. Answer is there. Answer is written on the copy sheet. He cannot stick the copy sheet to the answer book. So what he has to do? He has to read from that sheet and write it. So at least one word memory he must have. He reads a word through his eyes, it enters somewhere and he has to write through hands. So that some temporary memory is also required to be within, even though you have large outside memory, that is the copy sheets, but some temporary memory, at least one word, one sentence. So similarly, the CPU inside it is having few memory locations. Also, one byte, that is group of 8 bits, is universally referred as one location. Some convention, why 8? There is no answer. For why it is 8, there is no answer. Somehow, why not 16 taken, or why not quad taken? So just 8 bits is one location, and it is internal memory to CPU. Internal memory. What exactly memory location is, that also I will explain. This is internal to CPU. It is also called as registers. Internal memory is also called as registers. Now, what is a memory location? What is a memory location? So we have to go with those details. What is a memory location? So I think I have this, or I will explain here. What is a memory location, that I will explain in a very systematic manner. That I will explain it. What is memory location? I will explain to you 1 bit memory. 1 bit memory. That is, it is a flip-flop. Actually, the flip-flop fundamentals right now, those who might have done vocational electronics or computer may know, but in fact we should have dealt it in the first module, but that will take much time, so we resume few things and we will go in the details at a later stage. So, this is a digital circuit. This is a digital circuit which is having one input pin. This is, I am explaining it without going into the details of actual construction. It is here, what is a digital circuit? A digital circuit is comprised of gates. So it is comprised of various gates. The digital circuit is comprised of various logic gates. A circuit which does not have feedback is called as combinational circuit. The circuit which has got feedback is called as sequential circuit. Flip-flop is a sequential circuit. So some kind of arrangements of gates is there inside. Then this is a flip-flop which is having an input pin D, an output pin Q, and another input pin called as, it is latching, so we give it as E. So this is called as D flip-flop. This is called as D flip-flop. Working of D flip-flop is very simple. That this flip-flop is having memory capacity. I will write a truth table for this. E and Q. When E is equal to 1, Q is equal to D, and when E is equal to 0, Q is old state, old Q. that I will explain again. When E is 1, when this is latching enabling input. When this E is 1, whatever you can give input 0 or logic 0, logic 1. That much digital fundamentals everybody knows. So when E is kept as 1, whatever you put on D gets transferred to Q. Whatever you put on D gets transferred to Q. I will explain because this is very much required. Whatever you put on D gets transferred to Q, and when you make E0, Q maintains its previous state. So it is remembering now, and that is irrespective of input. So the flip-flop, by the virtue of what is called as a state, because of the feedback in the sequential circuit, there is remembering capacity, and because of that remembering capacity, it is able to remember the previous state. That is a very big breakthrough in digital circuits. So suppose if I am having D is making changes like this, and this is D and this is E. What would be Q? What would be Q? What would be Q here is question mark. We don't know right now. But whenever E is 1, whenever E becomes 1, that time Q follows D. And whenever E becomes 0, listen very carefully, this is extremely meaningful information. Whenever E becomes 0, whatever is Q is continued irrespective of input now. So, in the duration when E is 1, input appears on the output, and whatever is the output at the time of falling edge of E continues till E becomes 1 again. So here the input has changed to 0, but output doesn't change, output continues to be 1, and output will become 0 only when E becomes 1. E becomes 1 and will remain 0 now. Even if again D becomes 1, here it will not change. So the D flip-flop follows when E is 1, and now I have made this E, I have made 1 for longer duration, that time it completely follows. And even if it becomes 0 here, it will continue to be. So this is very fundamental. This is the concept of memory block. With mobiles at your hand now, you are knowing gigabytes, terabytes, lot many things. But what is the fundamental of that? That everybody must know. That the fundamental of that is 1 byte. Gigabytes you call about, gigabytes, what does that mean? Then you also call terabytes, megabytes, internal memory, external memory, SD card capacity, and so on. So that is the fundamental is bytes. The byte is made up of 8 bits. So what is 1 bit memory location, that everybody must know, and that is this D flip-flop. it has got two inputs and one output. This D flip-flop has got two inputs and one output. Those two inputs are D and E, D and E, and output is Q. This E is latching enable, or to be very precise, just instead of E, we better to call it as latch enable. Latch enable you can call. So this latch enable is like writing, and after writing is over, whatever is written is continued. Whatever is written is continued in the memory. So this is a single bit memory location. Single bit, or no need to use word single here, you can have simple word, 1 bit memory location. One bit memory location. Is it clear? So whenever latch enable is 1, that time whatever is available on the input appears on the output, and when it becomes 0, when latch enable becomes 0, the flip-flop or the single bit memory location continues to store the previous state. The single bit memory location continues to store the previous state, and the previous state store is this one. So even if this changes, it doesn't, even if now this latch enable becomes 0, whatever was Q continues, and even if this B becomes from 1 to 0, there is no change in the output. So output continues to hold whatever was its state when latch enable was 1. So when latch enable is 1, output, the input is transferred to output, and when latch enable becomes 0, the previous state of the output is continued. Previous state of the output is continued. So thus, using latch enable, you can write in the memory location. So at the time of latch enable 1, whatever is here is punched inside the memory. Whatever is here is punched inside the memory, and that is continued till that latch enable is becoming 1 once more. So as long as it is 1, the things are transferred, and when it becomes 0, the things continue. So this is 1 bit memory location. And here there is interesting thing I have put. Latch enable 1 for longer time. So input is 0, that is transferred. Input becomes 1 in between, that also gets changed. And when latch enable becomes 0, output continues. Now input changes, it will not be reflected. So input changes which take place during latch enable equal to 0 are not reflected. Output continues to hold its previous state. So this is 1 bit memory location. Now we take help of 8 such locations. So if I have 8 such locations, what it would be? It would be 1 byte memory location. It would be 1 byte memory location. So what I can do? I can have 8 such locations. 8 such units. Each of them is having Q. Each of them is having D. Each of them is having LE. So this would be my 8-bit or 1 byte memory location. 1 byte memory location. How 1 byte memory location would be? This pin I will now call as bit number D7. The last is bit number D0. This output is Q7 and Q0. So there are 8 such single bit memory location. So 8 bits comprise a byte. This is D7, this is D6, D5. So there is convention, you start from 0 and not from 1. And what I will do about latch enable? Latch enable, I want to write entirely in the memory. So I will combine latch enables of all these flip-flops, all these single byte memory location, and that would be my common. That latch enables will not be separate. There will be common latch enable. There will be common latch enable. So this is overall latch enable. So an 8-byte or an 8-bit or 1 byte memory location would be 8 input pins, data pins, 8 output pins, and 1 latch enable pin. 8 input pins through which you can write, you can put the data, using this latch enable you can write, and 8 output pins which Q7, Q6, Q5 and so on. So this would be 1 byte memory location. So how to go for multiple bytes we shall discuss in the next part. I think it's better to stop now. Thank you.